Handing over to Scott from KiteAI.
Thank you. Hi, everyone. So what we built is first we built L1 for AI, the proof of attributed intelligence. My name is Scott. I'm actually come from industry background. So before this KiteAI, I founded a streaming DB company, got 44 million. And then before that, I would lead engineering, data infra engineering at Uber, so grow the team from myself to 200 full-time employee. I was also one of the founding engineer at Salesforce and Instant Data and AI Cloud. So I spent 15 years building foundational data and AI infrastructure. My team, my co-founder Chi, also come from an AI background. She was a founding engineer at Data, PM at Databricks, and AI PhD from Berkeley. So what KiteAI address? The problem we address, I think, is one of the biggest one. So currently, if you look at what preventing mass adoption of the AI, the first question is that is the model accuracy reach production grade? You didn't see this. You don't see a lot of the AI application in major apps like Uber, Apple, etc. Because currently, with the model hallucination, it still falls short of production grade standard. Another thing, people, for example, if you're asking Apple cannot use DeepSeek, Apple cannot use OpenAI. The reason is that they don't understand what's behind the model. The lack of transparency, like where is actually the data come from behind the model, is actually a serious question. That's why they're preventing them to use the model. The third question is this is actually from PyTorch last year. You can see like previously, before Gen AI, almost like 90% of data is public available and legally crawlable. But ever since Gen AI, company realized my most valuable asset, which is data, is crawling by the Gen AI company, and then they train a model, sell for billions of revenue, but they don't give anything back to the data company, or this small company who actually provide data. So forecasting that by the end of this year, more than 1/3 or nearly half of the data previously public available will become private. So that's the biggest challenge for mass adoption of AI. That's where KiteAI came to the play. We built this proof of attributed intelligence to solve the problem. The idea is very simple. Ethereum is giving $4 billion to a million validator doing exactly the same thing. Similar with BitTensor, give $1 billion in this case. So what we do here is that instead of instead of giving like a $4 billion for validator doing exactly the same thing, we want to redirect 90% of the block rewards to the AI contributor. So on the left-hand side, we want to have block incentive get to the AI contribution. On the right-hand side, we want to make sure have this end-to-end transparency, where the model come from, what data contribute to the model. In this case, the reward will give to the data contribution end-to-end transparently. So that's why we need build a layer 1 for this. The reason is that we not only use, if you think about the life cycle for a transaction, it's very different than compute. It requires a different life cycle. It requires a different latency. It actually requires a different commit as well in this case. So that's why we want to make AI compute as a first-class citizen. So if you look at, this is actually much simplified data model. If you look at transaction, it's more about who spent how much money, which token it is the from and to. From AI compute is more like who is a payer, who is a receiver for each of the model builder, data contributor, what's the payload for this. And the payload is actually pretty huge. With a long context, you sometimes can have like a payload as large as a book, like a 500-page book in this case. And also by putting AI compute first-class citizen, we will make sure the AI volume and AI compute can be, say, even in the light node. So in this case, you can calculate how much AI compute and how much AI compute, how much AI volume was spent and spent in the block level, and then when you do the reward distribution, it's much easier and clean. So even the light node has the full data. So that's why we embed this AI compute into as a first-class citizen. Also, the blockchain itself is actually pretty limited in terms of the compute and storage. We actually need to complement it with the data and the AI infra. This is actually detailed architecture for all the data and AI infra. Underlying, I don't know how many will come from infra background, but from data infra, underlying is built on top of Parquet, Iceberg, and Presto. We currently handle roughly 2 petabytes of data. This is 1/2 of the Netflix data scale. This is almost like 100x of data training in the GPT-4. GPT-4 only train on 13 trillion tokens. And then from the AI infra, currently we only support PyTorch. We have 10 plus AI use case deploy. We just deploy the PyTorch code in a Docker environment. We don't support multi-GPU yet. I think in future maybe we will support data multi-GPU. And also this is pretty hard. The reason it's pretty hard is that most of the new AI use case is actually multimodal. If you think about the traditional AI use case, it's more like machine learning, transaction data, particularly with blockchain transactional data. But multimodal data is actually very different characteristic. I'm going to go to one example before. So the whole purpose of KiteAI is that we want to build proof AI. So everything related to proof AI is our focus. Then we want to enrich the ecosystem with subnet. So all type of subnet is our focus. Data subnet, agent subnet. Currently we have some top subnet from near and then like BT and then from BTensor coming to us. If you are building a subnet, come to us and chat with us. Like one of the use case we do is with cancer detection. So this is actually a blood cancer detection use case. We work with UC Berkeley and MSK. What they do is that the data is actually very large image data, like 200K times 200K data. Each image data is like 2 gigabytes. This is actually cannot handled by traditional data infra. If you think about definitely not Postgres, but if even think about data lake, this cannot be compressed into the Parquet file. So that actually requires a little different modification for the data infra to handle. But what we provide here is that we provide a collaboration space for Berkeley to use the data beyond UCSF. Currently, they only have UCSF data, and then now they have the data access beyond UCSF. You can use in this case, data subnet called CoData. They have some data from Shanghai Renji Hospital for the blood cancer, noted blood cancer data. So together with this, they can build a state-of-the-art foundational model for cancer detection, and then there are a few customers waiting for this, and the revenue will be distributed through payment through the KiteAI network. So this, if you look at it below, you can see how the blood cancer cell looks like. It's a huge file with millions of cells, and each cell we chunk the cell and classify on each cell level. In this case, so in this case, we not only Proof AI platform not only provides them with infra, but also provides them with a marketplace of different data vendor, data subnet, like a different source of data to train a better model. Okay, so this is end of my presentation. If you are interested in become an agent subnet or data subnet, you can follow us and or follow me on Twitter. And I'm open to any questions if you have any.
I do have a question, very quickly, while you're there. Why, I can understand the design requirements on why you need your own blockchain, but what were some of the other decisions to have your own chain? Like, what were the other design kind of requirements?
Okay, so first, the most important thing, if you think about BitTensor design is purely based on staking. It's not take AI volume or AI performance into consideration. That's why we need, we need some customization. Hey, really reward AI contributor based on their contribution and based on the performance model in this case. And then if we don't put this into the light node, there is a many way to rig it in this case. And second and most important thing, if you think about this from pair to receiver, this is actually, if you do this in use existing ops code, and this is actually pretty expensive. It's actually grows, it's like exponentially cost. We want to make sure we actually has a new ops code optimized to make it the distribution. For example, a payment from a pair to a model builder, data contributor, the cost is linear, even less. This is actually a further optimization for blockchain. Third thing that, honestly speaking, I feel like the most immediate use case for agent block, we are building a blockchain for AI. The most urgent use case for AI agent is payment. Think about payment. Payment is actually a workflow. You cannot use a credit card or debit card for AI agent. And for example, if you want to rental a GPU in trustless environment, you don't want to pay upfront. You don't, the GPU provider don't want to pay afterwards. In this case, you probably have a cadence or release of the, payment to the, every 10 minutes, every hour to the GPU provider. So payment is always a workflow in this case. So that's why support AI agent payment on blockchain is one important thing. Actually, contradictory most of people's impression. blockchain payment is the most secure way because it's programmable. You can create a burner wallet to do the payment. In this case, it's actually secure than credit card, debit card. In this case, but you need to be done right on smart contract level. Yeah.
Perfect, lovely. Thank you very much. We will not talk about the legalities of that yet. But perfect, lovely. Round of applause, please. Thank you very much. Next speaker.